this is going to be the last example. What I want you to do is go to page 552, and you'll notice it says example 3. And you'll notice that there is a question on here that is very similar. Okay, very similar. But then there's another one where you have binomials. Okay, not just monomials, not just one-termed polynomials in the numerator, but you have like w plus 3 and w minus 1 and w plus 2. I want you to make sure that you know how to do that. That's kind of a little bit of an extension of this. But if you put together the last video and this video together, you will be able to figure out that. I just don't want to take, take 10 minutes to do it, because it takes a long time. But if you want me to do it in class with you, no problem. Alright, so what I want to do is I want to find out what the lowest common denominator between these guys is. Actually, first I can say the non-permissible values. We just, a cannot equal 0. Hey, guess what? 2 can't equal 0 either. Hey! 2 is never 0, because 2 is 2. So what I want to do, let's just go through what we did last time. So 5 over 2 minus 3 times 3 over 2 times 2 times a plus 2 over 3 times a. So our lowest common denominator. So it's no big thing. This 2 and this 2 match up, so we don't need to multiply again by it. So we have 2. We also have an extra 2 that doesn't correspond to anything, so we need to multiply by 2 again. This a corresponds with this a, so we multiply by a. But we have this a again. The only thing that's left is this 3, so we need to multiply by 3. So our lowest common denominator is 4 times 3 is 12a squared. By just looking at it here, you can absolutely see that the number bits, 2, 4, and 3, the lowest common denominator between the number bits is going to be 12. And the lowest common denominator between a squared, and a to the 0, what? It's just 1, is a squared. Okay? This is helpful to cover up what you have and then what you need to multiply by. So we have our lowest common denominator, which is awesome. I'm just going to move over to this side because I have a little bit more space. So we have this here. This is not proper form though, guys. We can really continue the problem underneath. So we know that our lowest common denominator is going to be 12a squared. I need to multiply my 2 by 6a squared, so to get to 12a squared, so that's what I need to do on the top two. So 6a squared times 5. This 5 and this 5 correspond with each other. Minus, because there's a minus between. What do I need to multiply 4a squared by to get 12a squared? 3. Minus 3 times 3. Just going to put a dot over the 3 so you know what that corresponds to. Now look at my denominator here, 3a. What do I need to multiply 3a by to get 12a squared? I need to multiply by 4a. Plus 4a times 2. I'm going to put a little heart over the 2 just so you know where it came from. Okay. Alright, so I'm going to simplify here. It's going to be 30a squared minus 9 plus 8a all over 12a squared. Now, what I want to do is I want to get this in like really nice form. So I'm going to switch out these two. Okay, I'm gonna exchange them. So 30a squared plus 8a minus 9 over 12a squared. Now I think, is there anything that I can factor out of here? No. That's why the lowest common denominator is like awesome. Because if you just multiply these guys together, 2 times 4a squared times 3, we would actually have 12a to the 3, and then we would have to factor out an extra a on top. Ooh. Okay, you doing the lowest common denominator means we don't have to factor out or cancel anything. It's just, it gives us the answer in the most simple form.